All right, so this is our last lesson with the logarithm chapter here. And basically, if you haven't gotten it already, logs are exponents. And so you'll see us using both of them interchangeably throughout this entire chapter. And we're going to have quite a bit of practice even after this video to prepare for the test. Bottom line is, when we're dealing with logs and exponents, it helps if they have the same base. That's the only way that we can multiply them. It's the only way that we can subtract them. It's the only way that we can do any sort of operation, solve them or what have you. So when we're looking at questions like you see here with 1, 2, 3, and 4, the idea is that we need the same base. And when I look at that first example, 4 log base 2 of 7, the question that needs to ring through my mind is, can I get them to be the same base? And so that is our goal today, is to be able to solve logs that have unique powers. And hopefully by the end of this short lesson, you'll be able to do just that on the homework questions that I've assigned to you today. Okay, so the first part, I just already worded the problem here. We want to get them to be the same base. So when I look at that log and I see that that has a log base 2, what I want to be able to do is to write this with a base of 2. And of course, I hope it's very obvious to you that that is 2 squared. And so I say, okay, that's 2 squared log base 2 of 7. So just rewriting the 4 there. Now, what happens here? We have 2 squared, and then we're raising it to that power. So what do I do to those 2? We multiply them, right? So really, this is what this is. Now let's look at this. I'm going to cover up for a moment. If I, let me just use a little shape here. I got to fill it in. So I got to move this little recording dude here. Sorry about that. So I'm just going to do just a gray fill here. If I was to cover up that 2, and we are to look at this question here, 2 log 2 7, just in the lesson that we learned previous, we remember, at least I hope you do, that this 2 actually, when we write a log, would have come from here. So in other words, this could have been written as log base 2 of 7 squared. And so now we just kind of move that little square, and we say, okay, so then that means that 2 was written here. So what we now have is 2 log base 2, and as I've said to you in the previous question we were solving those things, previous video anyway, those 2 in essence cancel out. They get rid of each other. They're what we call inverses, and so they do actually like remove each other. And so what we're actually left with here is 7 squared, and so my answer is 49. You probably never saw that answer coming from that question. Let's look at another. Okay, so now 32 to the x equals 64. The only way really to deal with this is if we can get them to be the same base. Whether we're dealing with exponents or we're dealing with logs, the idea is that we're writing it with the same base. You have your 2 charts. Hopefully you're very familiar with these 2 in particular. How can I write 32 and 64 using a base of 2? We can see that they're even, so is there a way? Absolutely. This is 2 to the 5th, and that's raised to the x power, and then this is 2 to the 6th, right? All right, so what do I do to these exponents? Because I'm 2 to the 5th raised to the x. So yeah, we multiply them. And so now I see that they're the same base. How do you suppose I can handle that question? How could we solve for x? Well, if I want these exponents to be the same, because that's what we're doing, then what I want to do is say, okay, then 5x equals 6, so then x must be 6 divided by 5. And that is the answer that I'm looking for. That means then that 32 raised to the 6th fifths equals 64. And of course that just tells me that I'm going to do the 5th root of 32. I'm going to get it down to 2, and then I'm going to raise it to the 6th power. That's all that meant to do. Let's look at this next one. In this next one, it says 8 to the x equals 1 over 16. Why don't you go ahead and try this one for yourself? In just a few minutes, I'm going to come back, probably seconds actually, depending on how long it takes you to do. But I would like you to come back and then listen to me explain that. All right, hopefully by now you've paused the video and you're back with me. So here we go. We're going to get them to be the same base. So again, this is 2 cubed raised to the x. And this would be written as 2 to the negative 4 because it's flipped, right? And so again, we have 2 to the 3x equals 2 to the negative 4. And so we want those powers to be the same. I'm going to set 3x equal to -4, and I get x equals -4/3. Wonderful. This last example that I'm going to do with you today is 125 to the log base 5 of 25. Whether we're dealing with exponents like you see in 2 and 3, or you look at 1 and 4, you say, what do I have to do? I need the same base. We want this to also have the base of 5. So again, that means that's 5 cubed. And so then I would have log base 5 of 25. Hopefully you can readily see that they would in fact multiply because we're raising a power to a power, and that's what we would do. Again, as we pointed out before, that 3 then could move, because another way of writing that log would be 5 log base 5 of 25 cubed. Now that the 5 and the log 5 are next to each other, you can actually get rid of those, and we could say my answer then is 25 cubed. And that's not a great answer. Another way that we could do that is 5 squared cubed, which would mean 5 to the 6th power. And we could calculate it that way or just leave it at that. For these rather large numbers, I'm not expecting that you actually would multiply those out. Given the fact that you don't have a calculator, more than likely on the CLEP exam, if they were to ask such a question, that it would either be on the calculator portion so that you could calculate that, or it would be a number that's manageable enough that you would actually be able to do that in your head. Understand the two charts are not provided to you on the CLEP exam, nor will you even need them. Any question that pertains to logs or high exponents, you should be able to do them in your head or quickly on the side of your scrap paper. So that just hopefully alleviates any stress with that. They do have enough questions out there that we don't need super high, like 5 to the 6, without a calculator. And if we did, we would put it on the calculator portion to examine whether you understood that rule. So there you have it. That commences the unit on logarithms, and hopefully with the practice that we have set up for the next few days, you'll be very prepared for the next test.